Okay, let's go to number one of the density problem. Okay, number one, you have a rectangular block of an identified material, has dimensions 5.0 by 15 by 30 centimeters and a mass of 2.50 kilograms. What is the density? So you are not told what set of units you're going to use, whether if it's going to be MKS, CGS, or FPS. So here, since we have mixed units, kilograms, and this one is going to end up as cm cube, we have to convert everything to MKS. Okay. So in number one, you're asked for the density rho is equal to mass divided by the volume. Our mass is 2.50 kilograms. And for the volume, this is a rectangular block, so we do length times width times height, but we need to convert this to meters. So in meters, this would be 0.05 meters. Okay, 15 would become 0.15 meters, and for 30 cm, this would become 0.30 meters. Okay, um, this is length times width times height, which is the formula for a rectangular block. Okay, the volume formula for a rectangular block. Okay, for when you're going to compute this, okay, when you press this in a calculator, don't forget to put this in a parenthesis. Okay, so 2.5 divided by all these three, this will give you 5.0 kilogram per cubic meter. Okay, so we end up with 2SF because the one with the least number of significant figures would be 5.0. Number two, a cylindrical aluminum rod has a length of 84.0 cm and a diameter of 0.60 cm. Okay, what is its mass in grams? So you are expected to have your final answer in grams, okay, CGS unit. Okay, so to be able to solve this problem, you have to take a look at the density of aluminum, which can be found in page 145 of your textbook. Okay, so in page 145 of your textbook, you have the density of aluminum 2,700 kilogram per cubic meter. Okay, page 145. Okay, so you have there in page 145 the table of density. Okay, you are asked for the mass. So we know that the formula for density is mass divided by volume. Therefore, mass is equal to density of aluminum times the volume of the aluminum. But in this case, the volume is that of a cylinder. Okay, for a cylinder, the volume is V equals pi r squared h. Okay, we can compute for the pi r squared h first. Okay, or just substitute na lang into this. Okay, so you have the mass is equal to 2,700. Okay, the equivalent unit of the equivalent value of 2,700 in uh, CGS would be 2.7 grams per cm cube. Okay, this is what we need. So we delete this. This one should be 2.7. This one is 2.7 grams per cm cube multiplied by the volume. The volume is pi. Now the radius, we have to divide this by 2. This should become 0.30 because you are given the diameter. So kailangan divide by 2. Okay, so 0.30 cm, then square. What is the height? Okay, so 84.0 cm. Okay, so computing for the mass, you get 64 grams. And our answer should be in 2SF. Okay, let's go to number 3. In number 3, a brass block with a mass of 0.50 0 kilograms and a density of 8.0 times 10 raised to the third kilogram per cubic meter is suspended from a string. What is the tension in the string if the block is in air? Okay, so there is a string attached to the brass block. Okay, so to compute for the tension, tension is the upward force. Okay, weight is the downward force. Okay, since this will be in equilibrium, the sum of the forces along the y-axis should be equal to 0. And what are the forces along the y-axis? The tension going up and the weight going down. This is equal to 0. So tension is equal to just the weight of the object. Since this is in air, okay, we can just convert zero point 0.5 kilograms, the weight, just convert it to newtons. This will give you 4.9 newtons in air. Okay, so we are done with the first question. If it is completely immersed in water, okay, there's going to be an additional force. We call that the buoyant force because the water will exert an upward force. Okay, so the formula becomes tension, okay, minus Fw because Fw is downward plus the buoyant force, which is the push upward. They are all equal to 0. So the tension would be Fw minus the buoyant force Bf. The Fw of the string we computed, the Fw of the brass block, okay, is 4.9 newtons. How do we compute for the buoyant force? The buoyant force is equivalent to, okay, the apparent loss of weight of the block. Okay, because this one is in air, we have to compute for the apparent loss of weight of the block. Now, how do we get the apparent loss of weight of the block? Okay, by getting the volume of the block that was submerged. Okay, so we first compute for the volume of the block using density and the mass here. Okay, we know that density is equal to mass divided by the volume. Volume, therefore, is equal to mass divided by the density. So we transform the equation. Okay, the mass given is 0.500 kilogram divided by the density 8.00 times 10 raised to the third kilogram per cubic meter. Cancel, cancel, you will end up with meter cube. So the volume that you will get here is 6.25 times 10 raised to negative 5 cubic meter. This is the volume of the brass block, and this is also the volume of water displaced. They should be equal. Since we know the amount of water that was displaced, we can compute for the mass of water that was displaced. Okay, so what is the mass of the water displaced? Let's put it here. The mass of water displaced is equal to the density of water, which is 1000 kilogram per cubic meter, multiplied by 6.25 times 10 raised to negative 5 cubic meter. This will give us 0.0625 kilograms. What is 0.0625 kilograms in terms of newtons? We multiply this by 9.8, okay, to get the newton. So the buoyant force is 0.0625 times 9.8. It's going to be 0.6125 newtons. Okay, 0.6125 newtons. So now we can continue with this. Okay, we substitute Fw is 4.9 newtons minus 0.6125 newtons. Okay, this will give you an answer. T is equal to 4.3 newtons. This is now the tension on the string here when when the brass block is completely submerged in water. Okay. Number 4. In number 4, you have an ore sample, okay, weighs 40 newtons in air. When complete when the sample is suspended by a light cord and totally immersed in water, the tension in the cord is 9.00 newtons. Find the total volume and density of the sample. Okay, so you have the weight in air, which is the true weight, kasi yung 9.00 newtons is a fake weight. Okay, from the true weight, we can get the mass. The mass, if you multiply this by 1 kilogram all over 9.8 newtons, you will get 1.428 kilograms. This is the mass of the ore sample. Okay, in water, submerged, the FW, the apparent weight is now 9.0 newtons. So there's a loss of 14 minus, okay, apparent loss. Kaya tinawag na apparent because it's a fake loss, no? So 14.00 newtons minus 9.00 newtons, this will give us 5.00 newtons. Okay? Now, this 5.00 newtons, we can get the amount of water that was displaced by converting this to kilograms. So 5 divided by 9.8, you will get 0.5102 kilograms of water. Okay, this is the amount of water displaced. Since we already know the amount of water displaced, we can compute for the volume of the water displaced. And whatever is the volume of the water displaced, that is the volume of the ore. Okay, so we use the equation density is equal to mass divided by volume to compute for the volume of water displaced. Okay, so this will end up as V is equal to mass divided by the density. The mass of water displaced is 0.5102 kilograms. Um, the density of water is 1000 kilogram per cubic meter. Okay, this will give us 5.102 times 10 raised to negative 4 cubic meter. This would be the volume of water displaced. Okay, this is the volume of water displaced. Since this is the volume of the water displaced, also the volume of the ore. Okay, by the water displacement principle. Okay, so the volume of the ore, we already know. Ito na siya. 5.102 times 10 raised to negative 4. We just follow the rules on significant digits. This should be 5.10 times 10 raised to negative 4 cubic meter. So density na lang tayo ng ore. So the density of the ore is equal to the mass of the ore, which is 1.428. We have it here, divided by the volume of the ore, 5.102 times 10 raised to negative 4 cubic meter. This will be 2,800 kilograms per cubic meter. Okay, our answer should be in 3SF, so there should be a bar on top of the first zero para 1, 2, 3. Okay, number 5. When an iceberg floats in seawater, what fraction of its volume is submerged? To compute for the fraction submerged, we have to get the specific gravity. So the formula, okay, is the percentage submerged. But in this case, it's going to be the density of ice over the density of seawater. We have to look at uh, the density. So the density of ice is given in page 145 of your textbook. It's 917 kilogram per cubic meter. And for seawater, um, it is 1027 kilogram per cubic meter. So this is the specific gravity. Just multiply it by 100. Okay, you will get 89.2% submerged. But the question is asking for, wait, fraction. So it should be expressed in fraction form. 89.2 over 100. Okay, so parang 892 over 1,000. This is equivalent to 892 over 1,000. And then just reduce this to the lowest term. So 892, and this is going to give us, this is reduced to lowest term 446 over 500, still divisible by 2. So it's going to be 223 over 250. This is the fraction. All right, thank you.